Hello. Let's get started. Hello, everyone. My name is Luca. I'm the CTO at Serenita, where we specialize in staking Ethereum. Just out of curiosity, how many people here in the room have heard of Vero before? Okay, cool. So yeah, today I want to talk to you about client diversity, the importance of it, why we decided to develop Vero. So yeah, let's get started here. For those who don't know, client diversity, just wrapping it up real quick, is the concept of Ethereum not relying on a single client implementation, but instead relying on different client implementations, and that way we don't get like chain halts and that sort of stuff on Ethereum. So if we have multiple client implementations of the protocol, we get a lot of resilience because it's very unlikely that all of the clients would suffer from the same bugs. Currently on the client diversity side, there's a lot of choices that node operators can make. There's 6 different CL client implementations, consensus layer, and 5 different execution layer implementations, and we're probably going to get a few more. In ideal conditions, that would mean that each client is used by about like 17% of the network on the consensus layer side and about 20% on the execution layer side. We know that the actual client usage distribution is a bit different, so it's not as ideal as it looks on the charts on the right. The question arises, do we actually need client diversity, right? Is it worth going through all the trouble implementing all those clients? And I would argue that we actually do. And to support that statement, I've kind of summed up all of the client bugs that we've seen over the years. This is well, I wanted to like sum them all up in one slide, but I didn't manage to because there were quite a few. These are not all the client bugs that we've seen. These are only the ones that actually affected consensus. So these are the ones that actually made clients like end up on different chains or not accept valid blocks, that sort of thing. So these are the client bugs that we've seen on during the proof of work era of Ethereum. I wasn't around for many of them, so I don't know like too many details on most of them, but I think about 3 of them made it to mainnet, so they actually affected mainnet operations for some time during proof of work. Moving on to proof of stake, where I was already involved quite a bit, we see a couple more bugs here. The first one during 2020 was before the beacon chain even launched, so this was on a very early testnet, but it affected the testnet in a huge way. A lot of the testnet validators were running Prism, which had a very interesting kind of bug, which made Prism think that it was actually it basically like won't Prism's time ahead one full day. Then it got quiet for a few years, but last year in January we had like 2 bugs hit mainnet. One of them affected Beso, and the other one only 2 weeks later affected Nethermind, which kind of revived the whole client diversity discussion, which was nice. People actually started moving away from Geth after these 2 bugs happened. In March of 2024, there was a nasty bug on the Gurley testnet. And just this year, in February and March, we had some testnet bugs on the Holeshki testnet and Sepolia. These were quite big, and I would like to just go into a bit more detail on the Holeshki incident. I could talk about this one for like the full talk, but I'm not going to do that. If anyone's interested in the full detail, I would recommend you guys to watch the protocol Berg talk that the Lodestar team did. But just quickly going over it, so the Spectra upgrade was scheduled on Holeshki on the 24th of February, and so it was scheduled at 9:55 p.m. and only a few minutes later, something happened on this testnet at like 6 minutes into the network upgrade. At this point, it was not really clear what was actually going on. So there were like some initial symptoms. Some clients reported blocks as invalid. Some thought they were okay. We saw a bit low participation rate on the network. So like even half an hour in, I think, it wasn't really clear what's going on. And people thought like, okay, some people just forgot to update their nodes. So yeah, in the end, it turned out to be a big consensus bug. And like about an hour after the bug manifested, we see a comment from Julio he's from Aragon, right? So yeah, he posted that, okay, actually Aragon and Reth is in the right here, and all those clients that were mentioned here, like Geth, Nethermind, and Besu, were actually on the wrong fork. So this kind of got ugly. In the end, like this was more than an hour later, and at that point it was finally clear what is actually going on. At that point it was already kind of too late because some validators have started to vote for the buggy chain to finalize. So a few hours later, it was really hard for all of those validators on the correct chain to actually sync up and like validate proposed blocks. And in the end, the Holeshki testnet was basically deprecated in a way, and a new testnet had to be spun up. So how bad do these things get? You could see like the worst case scenario, right? But I wanted to explain like it depends on many things. So in the ideal scenario, all the validators are on the same chain. They have the same view of the network. But in a buggy client scenario, I wanted to show like this is a case where 20% of the validators end up on the wrong chain. So they have a client that has a bug. In case only 20% of the validators is affected by something like this, the impact is pretty negligible. Ethereum never loses finality because those 80% of the correct chain validators are able to just like continue going. In a case where 40% of the validators start following the wrong chain, things get a bit more messy, and it very much depends on how this client bug manifests itself. But the worst case is that these 40% on the buggy chain end up starting to vote differently than the ones on the correct chain. And this may, in the worst case, result in up to 7 ETH of your stake being lost. So that's about a quarter of the stake. And then the correct chain would take 12 days to finalize again. And then we have the worst case, which is basically what happened on the Holeshki testnet, where in this case we have 70% of the validators on the wrong chain. In this case, all of those 70% of validators are able to finalize this buggy version of the chain, which means the correct chain stops finalizing. Once the buggy chain finalizes, it's really bad because the validators that ended up voting for this chain have no way to go back to the correct chain. The impact of this is pretty huge. You basically risk losing the entirety of your stake in this case. Finality would only return to Ethereum in several weeks. And the scary part is also that for this to happen, we only need to have 2 simultaneous client bugs on Ethereum right now. So circling back to the Holeshki incident, where 3 EL clients had the same kind of consensus affecting bug and ended up like voting for it to finalize. I would say it's not that what's the word here? It's not impossible for it to happen on mainnet, right? So with this talk, I wanted to go further and not just like hope that it doesn't happen on mainnet, but let's actually aim for it never to happen on mainnet. There's a couple of approaches how to get there. I'm gonna start with the simple approach where we reduce the impact of client bugs by like spreading your validators across different client implementations. Say you're running 3,000 validators, you would split them up into like parts of 1,000 each, and you'd connect those to separate client pairs. This is very easy to set up. It's good for the network, and if everybody did this, then we'd be in a very good place. But reality is different. In this case, the impact of a single client bug can still be significant because it could still affect like 1/3 of your validators. Then there's a couple more advanced approaches, one of which is running Vouch. Vouch is a multi-node validator client, which is able to combine data from multiple client implementations. And basically, if you run Vouch with a combination of these 3 clients and you set up the majority attestation strategy, Vouch will use those 3 nodes and make them basically agree on what the correct state of the chain is. So this is a very good kind of setup. It's used by many professional node operators already. And I also put it as a con, this fact, because if Vouch ends up having a bug, you basically need to wait for Vouch to get fixed. And since so many different node operators also run Vouch, you basically are all offline at the same time. So that could be not so great. Then there's DVT, 2 implementations, SSV and OBOL. In this case, you'd like split up your validators into different validator shards, and each shard would, each like part of that validator would need to agree with the rest of the cluster to come to consensus and attestation on what to like attest to which chain is correct. So today I found out that SSV doesn't fully do this. So if you're running SSV and you think you're protected against the type of client bugs that I'm talking about, then it's not completely true. But yeah, if you want to know more, then just talk to me after the presentation. Then what will we have? The more advanced approaches that I just mentioned, what do they have in common? Basically, they're pretty complex to set up. And they're like, if you want to switch them, it involves a lot of complex operations. And if you want to switch back, it also is not that easy because you have, like in the case of, in the case of SSV or DVT, you need to like split up your validator keys. And in the case of Vouch, you need to use Vouch's remote signer implementations. So this got me thinking, can we reduce some of the complexity while still achieving the same result of avoiding these client bugs? That's what made us implement Vero. Vero is a multi-node validator client. It's very simple at only less than 4,000 lines of code. It's secure, it never has access to validator keys directly. It's highly observable, so it gives you some nice metrics, statistics, and it's compatible with all the CL client implementations. So Vero being a multi-node validator client, what does that mean? It means that just like Vouch, it can talk to multiple client combinations at the same time and combines their output. This way, even if one of the clients goes down or it ends up on a different chain, Vero just continues going because it only needs 2 out of the 3 clients in this case to agree on what the correct chain is. So this is a short summary of the pros and cons that Vero has. It's obviously not biased at all. These are some of the metrics that you can get out of Vero, so you can see exactly at which point into the slot it attests. These are all included in the GitHub repository. It also exports tracing data, so this is really useful if you want to like figure out what went wrong during your blog proposal, which part of the blog proposal took too long. One other thing that Vero can do is it listens to slashing events happening across the entire network. If it detects that any of the validators it manages got slashed, it actually stops performing all of its duties. So that prevents further validators from getting slashed. So this is what it looks like on the dashboard. This is the normal state of things. Everything's working. Duties are being performed. And then once a slashing event is detected, it just shuts down all duties. So you don't have to like react yourself. The software reacts automatically. If you're feeling a bit like this and would like to try out Vero, this is how easy it is to get started. So say you have a very simple kind of setup with a consensus layer client, execution layer client, and your validator client. What you need to get started is you need to move your validator keys out of your validator client into a remote signer. So that's the first step because Vero never has access to the validator keys directly. It just doesn't want that. Once you have those keys in the remote signer, it's very easy. You just swap your validator client out for Vero. It just uses the same kind of flags. It's very easy to do. Once you have that, I would say you should get started running different clients. So spin up some additional client implementations, additional client pairs. I would also recommend going with some of the minority clients. So in this case, showing by Lodestar, Reth, Grandine. Once you have those spun up, you just check on their performance, see if they're like working well, set up your alerting, all of that. Once you're satisfied with that, you just point Vero at all 3 client combinations, and that's it. That's as easy as it is. Just to prove how easy it is, this is the command line, like the command that you need to run. So you just say that you want to run the Vero image. You say where Vero should go to find the different client implementations, and you show it where to find the validator keys. That's it. So with a 3-node setup that I showed in a few slides back, your setup is completely immune to any single client bug, no matter like how many different validator operators run that client on the network. It doesn't matter. You're completely immune to any single client bug. You can perform maintenance on one of the client pairs anytime you want. And yeah, of course, this kind of setup helps make Ethereum more resilient against client bugs. If you're a professional node operator, you can also go a bit further, get busy with a 5-node setup. In this case, you would basically run 5 different CL clients, 5 different EL clients. If you manage to do that, you can like ramp up this setup to be immune up to 4 different, well, to a bug that is shared by up to 4 different clients. So that's really cool, and I don't think you can really like configure this with any other approach. Okay, the goal of this talk and the goal that I have in mind with developing Vero and working on this is to get 40% of the network onto a client bug resistant setup. So I think this mainly lies on the professional node operators on the network. I don't think we can really expect home stakers to be running like 5 different client pairs. It's a bit too much. But yeah, the home stakers don't make up the majority of the network, so I don't think it's their responsibility. Yeah, and if we get to this point, we never actually will get to finalize a buggy version of the chain, which is like a huge thing. Because like if we actually do end up finalizing the wrong version of Ethereum mainnet, that would just be a huge catastrophe. And yeah, it's something that Ethereum may not even be able to recover from, right? So yeah, this is the way we run things at Serenita. We run 5 different CL clients and 4 different EL clients at the moment. So our setup is completely immune to, I think, 2 client bugs at the moment. I would also encourage other professional node operators to run such setups. It's up to you to step your game up. Just because you're happy with the current client combination you're running doesn't mean that you're always going to be happy. If that bug strikes, then you're not going to be happy, and it's going to be too late to do anything about it. So yeah, that's it for today, I think. If you want to learn more or stay in touch, here are some links. You can follow us. And yeah, I think I'll leave it up to you guys now. Thanks for being here. Any questions? Sam?
How does it affect the latency?
Not as much as you'd expect. Basically, if you're running like 3 clients, it takes the fastest 2 of the 3 responses. And since those client pairs all execute transactions in parallel, it doesn't add a lot of latency.
Got it. And even if these different client combinations are not in the same location?
Yeah. We run ours across Europe, so across a single continent is fine. Once you would want to like run it across the globe, it may be different, but yeah, I haven't tried it yet.
Okay, thank you.
Thank you. So if you're running an operating system, there is risk that the operating system may not be maintained. And we choose Ubuntu LTS. So that long-term support thing is quite important to us. What assurances can you offer the community that this is Vero is LTS?
Yeah, that's a good question. I think the best I can do right now is, as long as we're in business, Vero is in business as well.
Thank you. And could I ask press a little bit further into this? How many developers do you have working on Vero?
It's just me working on this right now.
Okay.
But like as I said, it's very simple. So it's less than 4,000 lines of code. I think anybody could get started with it quite easily.
Okay. And do you have any backing?
Just our own.
Just our own. Okay.
Internal
thank you
backing.
so much. And
yeah,
thank you.
We received a grant from the Ethereum Foundation, just to be clear as well. But yeah, mostly it's us funding it.
Thank you so much for producing it. It sounds amazing.
Yeah, sure. One more question?
Yeah.
2 more questions, actually.
Hi. So have you put any thought how would this react with a Holeshki type incident? Because it sounds to me like potentially you would be helping finalize the wrong chain. I know that's a like very catastrophic type of scenario, but maybe, I don't know, stop like voting because like, I don't know. Have you put any thoughts on such a scenario?
Yeah. So the thing you can configure is what we call the consensus threshold. So if you're running 3 nodes, you can set the consensus threshold to 3 out of 3, and Vero would only attest if all 3 clients agree. So with 5 clients, you could set it to 5 out of 5. So if you wanted to and would want to be like really conservative, you could like up the thresholds all the way up, and then you wouldn't like vote on the wrong chain in any case, as long as one of the clients disagrees.
We should stop. So very short question, please.
Yeah, hey, this is Izzy. Like amazing piece of software, and I hope we can support it and get node operators using it off, like at least on Lido and Hoodie to battle test it out. My question is like about like the locus of dependency, if you want to think about it this way. So you use like Web3 signer basically as the only remote signer that you currently support. Are you worried about, so if you get to like 40% of stake running on Vero or Vouch, are you worried about over-reliance on like one specific piece of remote signing software?
Not that much. I think the worst case with Web3 Signer would probably be validator downtime, which, I mean, it's not great, but as long as the entire network doesn't run on Web3 Signer, it's also not catastrophic. Or did you also mean slashing wise?
Slashing wise and from like a key security perspective wise also.
Okay, well, slashing wise, I'm planning to add slashing protection to Vero as well, so there will be like 2 layers. And in terms of keys, like there's a lot of options you have with Web3 Signer, so I think that's also quite flexible. You don't have to like use the same way of accessing keys. So, yeah. Thank you, everyone.
Thank you for your talk. And yeah, if you want to talk to the speaker, we invite you to do it outside, so we can welcome the next one.